Hello, this is step 2, 2008, question 3, where we are first given the cubic y equals 27x cubed minus 27x squared plus 4, and we're asked to find the coordinates of the turning points, sketch the curve, and deduce that x squared multiplied by 1 minus x is less than or equal to 4 over 27 for all x greater than or equal to 0. So we first can differentiate and then set that to 0 to find the coordinates of the turning points. So that's going to give us 81x squared minus 54x, which is equal to 0. We can factor out the x, and we're left with x multiplied by 81x minus 54 is equal to 0, which gives us x equals 0 and x equals 54 over 81, or just 2/3 as our two x values for the turning points. And if we plug these back into the original equation, we can get that y equals 4 when x equals 0 and y equals 0 when x equals 2/3. This allows us to just draw our cubic, as we know now 2 points on it. We know that this is going to be 2/3 and this is going to be x equals 0, y equals 4, and these are our two turning points. And then we can deduce that x squared multiplied by 1 minus x is less than or equal to 4 over 27 by showing that when x is greater than 0, our cubic is greater than 0. So 27x cubed minus 27x squared plus 4 is greater than or equal to 0. Now 27x cubed minus 27x squared is greater than or equal to negative 4. Then we can divide by 27 and we get that x squared multiplied by x minus 1 is less than or equal to minus 4 over 27. And now we can multiply by 1 minus 1 to make this into x squared multiplied by 1 minus x is less than or equal to 4 over 27. So this is only true when x is greater than 0, so this holds for all x greater than or equal to 0, which is what the question asked for originally. Next, we were asked to prove by contradiction that at least one of the numbers BC 1 minus a, CA 1 minus b, and AB 1 minus c is less than or equal to 4 over 27. So first we have to assume that BC 1 minus a, CA 1 minus b, and AB 1 minus c are all individually greater than 4 over 27 strictly, and we can notice that if we multiply them all together, we can get that a squared, b squared, c squared multiplied by 1 minus a, 1 minus b, and 1 minus c will have to be greater than 4 over 27 cubed, as they're each individually greater than 4 over 27. Then we can rearrange this to the form a squared 1 minus a, b squared 1 minus b, and c squared 1 minus c, which will be greater than 4 over 27 cubed. And in the first part we showed that x squared 1 minus x is less than or equal to 4 over 27. So now we have three different parts, each less than or equal to 4 over 27 individually. So we can show that using the first part that this a squared 1 minus a, b squared 1 minus b, and c squared 1 minus c must be less than or equal to 4 over 27 cubed. But this is a contradiction to our assumption, so therefore at least one of these values must be less than or equal to 4 over 27. Next, we are asked to prove that at least one of the numbers p multiplied by 1 minus q and q 1 minus p are less than or equal to 1/4. So first we must assume that they are both greater than 1/4, that either this one is greater than 1/4 or this one is greater than 1/4. And we notice if we multiply them together that PQ multiplied by 1 minus Q 1 minus P must be greater than 1/4 squared. Now this is quite similar to the last part. If we separate these out, we get a P 1 minus P, Q 1 minus Q is greater than 1/4 squared. Except this time it's in the form x multiplied by 1 minus x instead of x squared multiplied by 1 minus x. So similarly to how we deduced x squared multiplied by 1 minus x is less than or equal to 4/27 using this equation, we can form a quadratic, namely y equals 4x squared plus 4x plus 1. And it's quite clear to see that this will be greater than 0 for all x greater than 0. And we can show this by differentiating. We're going to get 8x plus 4, which is greater than 0 for all x greater than 0. Then we can similarly do what we did for the first part of the question, where we set 4x squared plus 4x plus 1 greater than or equal to 0, which is true, and then we can rearrange this into a 4 multiplied by x squared plus x is greater than or equal to -1. So 4x multiplied by x minus 1 is greater than or equal to -1, and then x multiplied by x minus 1 is greater than or equal to -1/4, and then we can multiply by -1 again to get x multiplied by 1 minus x has to be less than or equal to 1/4. Now using this we can apply this to these here. So p multiplied by 1 minus p 1 minus q 1 minus p individually must be less than or equal to 1/4, multiplied by q 1 minus q, which must be less than or equal to 1/4. But in our assumption we showed that it would be greater than 1/4 squared, so we've shown that it's both greater than 1/4 squared and less than or equal to 1/4 squared, which is a contradiction. Therefore either p multiplied by 1 minus p is bigger than 0, less than or equal to 1/4, or q multiplied by 1 minus q is less than or equal to 1/4.